Okay, here we are. This is going to be a combined lesson of section 5.2 and 5.3. And to be honest, my lectures they're kind of they fudge the guidelines of what the book's doing. It's the same material, but it may not be exactly the same. So if you're trying to follow in the book, sorry about that, but I've got these prepared. Okay, the difference between 5.1 and what we're going to get into now is in 5.1 we were talking about sets and the actual elements in the set. When you go to 5.2, we're not worried about exactly what the elements are, but we are worried about how many there are. So I've prepared a couple easy things to kind of get us going here. So we're given three sets. Set A has all the numbers 1, 2, 3, and so on up to 20. Set B has the elements A and B in it. And set C has the number 8 in it. Okay, so when we write it like this, when we put an N in front of it, that means the number in A. So as I look up here, how many are in A? Well, that number should be, get my thing right in here. It may be gone. This may be too big. I like writing with this one, but it might be too big. So we have 20 there. The number in B is 2, and the number in C is 1. Then we go down to how many are in the intersection of A and B. So as you look at these two, what is the intersection? Which elements do they have in common? Well, they don't have any in common, so the intersection would be the empty set, and the number in the empty set would be 0. What about A union B? Well, I've got 20 here, and I've got 2 here. 20 plus 2 looks like that's going to be 22. Notice I didn't want to write them all out. I'm trying to look at it and do it logically. Okay, what about over here? A and C, the intersection of A and C. Well, I've got 20 here and I got 1 here. Are we going to take 20 plus 1? Well, no, because what happens here, the 8 would be counted twice because the 8's actually part of this one. So the the intersection is 1. I'm getting ahead of myself because 8's in both of them, but the union, I've got 20 here, I've got 1 there, but the 8 is already in here, so I've actually only got 20. So we're going to be given a formula. If I want the number in A union B, I'm going to take the number in A plus the number in B minus the number, I'm going to run out of room, in A intersect B. That's what I don't like about this pen. I like writing with a pen, but run out of room too easily. So on this one, I took the 20 plus the 2, but there was none on the intersection, so I didn't have to worry about it. On this one, there were things in the intersection, so I took the 20 from A plus the 1 in C, but since the 8 was counted twice, I had to subtract the 1. That's what this formula tells you. That's the number in A plus the number, in this case it was C, minus the number of the intersection of A and C. Okay. My page is going to look a little different. I was trying to conserve on paper. So let's go to this example. So A has the elements A, C, and D. B has B, E, F, and G. Find the number of A union B. So that formula says to take the number of A union B. If I want to find that, that's the number in A plus the number in B minus the number of A intersect B. So the number in A is 3, the number in B is 4, and the number in the intersection, what do they have in common? There's no A's, no C. Okay, That's just minus 0, so that would be 7. I'm giving you an easy example here. There's only 3 or 4 elements in each one of those. Well, what happens when you got 100 elements here and 120 there? Then it becomes more realistic to use this formula. Okay, here's example 2. So using the formula, let's see, A has A, B, C, D, E, B has B, D, F, H. I want to find the number in the union. So the formula says the number in the union will be equal to the number in A. So how many are in A? 5. Plus the number in B, there's 4 there, minus the intersection. Okay, so they both have a B, they both have a D, so the intersection would have 2. So 5 plus 4 would be 9, 9 minus 2 is 7. Okay, example 3. Of course, you knew it'd end up being word problems. The problem says, a survey of 100 coffee drinkers found that 70 take sugar, 60 take cream, 50 take both, cream and sugar. How many coffee drinkers take sugar or cream? Okay, so that or, remember we talked about that, means union. So I'm going to use S and C, the number that you use sugar or cream, will be equal to it. Now I'm going to do is apply that formula. The number in sugar, number take sugar, plus the number that take cream, minus the number that do both. Okay, so let's look at it. So 70 take sugar. How many take cream? 60. And 50 take both. That's sugar and cream. Remember, that means intersection. So minus 50. So I'm going to take 70 plus 60 is 130, and 130 minus 50 is going to be 80. So there's 80 people that take either cream or sugar or both. Okay, so let's just talk about the whole problem here. There was 100 people altogether. What happened to the other 20? Well, that means 20 people don't take cream or sugar. Now that becomes important later because you're going to be doing some problems where you're going to have to logically figure out some things. Okay, let's move on. So we had that formula. I'm going back up here now. Here's the formula when you have two sets, A and B. What happens when you have 3? Well, then you got a new formula. I'll let that stick there for a while. It's also in your book. But if you want to find the number A, union B, union C, you take the number in A plus the number in B plus the number in C. Then you subtract the intersection of A and B. You subtract the intersection of A and C, and you subtract the intersection of B and C. And then you got to add back in to this. Now, let's take a Venn diagram. I'm going to just create one. When it has 3 elements. And let's say I just put the number 1 there. That means there's 1 element in that area. That's the intersection of all 3 of them. I'm going to try to explain why this formula is the way it is. Okay, so if I'm talking about the number in A, union B, I'm talking about how many are in any one of those circles. There may be numbers outside, but how many are in there? What's the total number that's inside the three circles? So if I take the number in A, that is included in A. So that means that 1 is part of this. And then the 1 is also in B, and then the 1 is also in C. So at this point, I've counted that 1 3 times. I only want to count it once. So you subtract the number of A intersect B. A intersect B is this little, the football shape region right there. That 1's part of that. So I'm going to subtract 1 for that one. And then the intersection of B and C is this one. So I'm going to subtract 1 again. And then I'm going to subtract A and C. I got them backwards there, but I'm going to subtract 1 there. 1 for each of the intersections. So now if you look at it, I basically counted the 1 3 times. Now I'm back to 0. So to count it again, I add on that intersection. Put it all together, that means I counted it 1 time. That puts a little logic to that formula. You don't need to know that. All you really need to know is be able to use the formula. Okay. So here's a typical problem. Marketing surveys. A leading mobile home service provider advertises its services in 3 magazines: Cosmopolitan, People, and Time. This is an old problem. I don't even know if those magazines are around. I'm not really into magazines. Anyway, we still do the problem. A survey of 500 customers by the mobile phone service provider reveals the following information. 180 people learned of its services from Cosmopolitan, 200 from People, 192 from Time, 84 for Cosmopolitan and Time, 52 from Cosmopolitan and Time, 64 people in Time, 38 from all 3. So we got 2 questions to answer. How many of the customers saw the manufactured advertisement in at least one of the magazines? Can you tell by the numbers? No, I couldn't even do that. How many of the customers saw the manufactured advertising in exactly one of the magazines? Okay, so you've got all those wonderful numbers, but the problem is you can't tell what's what. So that's where the Venn diagram comes in. So this would be my universal set, which means what are we talking about here? Well, this would be all of the possible people we're talking about, which up here it says a survey of 500. That means, I'm going to put over to the side, the number in U is equal to 500. So I'm trying to take that information up here and write it down here in some sort of form that makes sense. Inside that universal set, I'm going to have 3 circles. Okay, I'm going to have a circle for Cosmopolitan, I'm going to have a circle for People, and I'm going to have a circle for T. When you go up to your numbers up here, that 180, I'm going to change pins because that's going to be too big. That 180, that means inside here, the number in Cosmopolitan is going to be 180. But that 180 doesn't show up directly here. The number in People is equal to 200. And the number in Time is 192. '84 would be Cosmopolitan and Time. So I would say the number in Cosmopolitan and Time is 84. So now I'm putting into symbols. 52 I did that again. I said that wrong earlier. Cosmopolitan people was 84. Cosmopolitan and time was 52. And the number in people and time equals 64. And the 38 would be the number in cosmopolitan and people and time, 38. Okay, so all I did, I took what was up here and I wrote that symbolically down here. Now, let's start putting our numbers up in here. And you always start from the inside and come out. So this would be the intersection of all of those. I'm going to put a 38 right here. Now you can see why I switch pins. 38. And to be honest, I usually just go up. So the probability, the number in people or time, that's the little football area right there. So 64, if I take 64 and subtract 38, why am I subtracting? Because this whole thing is 64. I've already got 38. So 64 minus 38 is going to be 26. That number goes right here. Now we go up to the 52. That's the intersection of cosmopolitan and time. That would be this area here. So again, I've got 52. And I'm going to subtract 38 because I've already got 38 of them there. That's 14. So those two together add up to the 52. And then when we go up to here, that's the intersection of cosmopolitan and people. So there's 84 altogether. So if I take 84 and subtract the 38's already there, that's going to be 46. Okay, now, moving up the line. Time has 192 people. Here's time. But I've already got 14. I've already got 38. And I've already got 26. So I have to subtract each of those. So, get my calculator here. I could do that, but I want to make sure it's right. And that number is going to be 114. So that was for, what did I start with? That's for time. So there's 114 here. Moving up, people's got 200. But I've already got 46, 38, and 26. So I have to subtract those. 200 minus 46 minus 38 minus 26. And that's going to be 90. That number goes right here. And then for cosmopolitan, I'm going to start with 180. And I'm going to subtract these three numbers here. 46, 38, 14. Let's see. That's going to be 60, 98. That's going to be 82. And that goes right here. Okay, now there's one more number. And that would be out in here. That represents the people that didn't get it in any of them. So what I'm going to do, I'm going to add all of these numbers up together. So 82, I usually go across 46, 90, 14, 38, 26, and 114. And that's 410. That's 410 inside the circle. Go back up here, there was 500 altogether. So if I take the 500 and I subtract the 410, that means there's 90 on the outside of the circles. Okay, now we did all that work. Now let's go back and answer the questions. Number one here says, how many of the customers saw the manufacturer's advertisement in at least one of the magazines? That would be the number in A or B or C. I know I'm using A, B, and C. I should have used C, P, and T. That would be the sum of all of these numbers inside the circles, because it could be inside this circle or that one or that one. But I already did that one. That's 410. Number two says, how many of the customers saw the manufactured advertisement in exactly one of the magazines? Well, look at your diagram and see if you can figure it out. This number right here, what does that 82 mean? That means 82 people saw it in Cosmopolitan. Not people, not time, only Cosmopolitan. So I have to take the 82 there, plus the 90 that saw it in people alone, plus the 114, that's the number in time and all, and I'm going to add those numbers together. So 82 plus 90 plus 114, and that number is going to be 286. Okay, so what did we just do? We started out, we had this problem with all the words, and the first thing I did, I told you we're going to do a Venn diagram, but we needed to take and write this symbolically. And then using these numbers, I came over here to the Venn diagram and filled them in. Once I have all those filled in, then I can go back and answer the questions. Okay, let's see. I'm going to skip example 5. Let's see. I'm going to come back to that one. That one's a little more difficult. Let's do this one, and then I'm probably going to break and come back with the part 2 on this one, because I'm going to run out of juice. Number 6 says, at a shopping mall, 190 drivers were selected at random and asked whether they enjoy driving a minivan or a car. So those are our two things, minivan and car. Again, this is no problem. The results showed that 110 enjoyed driving a car, 90 enjoyed driving a minivan, and 30 enjoyed both a car and a minivan. So the number that enjoyed a car is 110. The number that enjoyed a minivan was 90. And the number that did both, so that means C and M, equals 30. Okay, here's our Venn diagram. I've only got 2 circles. I got car and I got minivan. Where do you start? You start in the middle. That's the intersection of the two. That number is 30. Okay, the number of cars in, I had 110 minus the 30. That number is going to be 80. And then for the minivan, I've got 90 altogether. I'm going to subtract the 30 I've already taken care of, so that number is 60. Okay, and let's go ahead and finish it off. So I have 80 plus 30 plus 60, that's 170. There's 170 inside the circles. Altogether, there was 190. So if I subtract 170, 20. That's the number here. There's 20 people outside of that. That's our universal. Okay, let's answer the questions. How many people did not enjoy driving a car or a minivan? That's the 20. How many people enjoy driving a car? So that means it's in here, but not a minivan. So the whole circle here is car. These 30 enjoyed a minivan. These 80 did not. 80 is the answer. Once you get the Venn diagram, it's pretty simple to see. Number 3, how many people enjoy driving a minivan but not a car? Well, that's the number on the air side. That's 60. And number 4, how many people enjoy driving a minivan or a car? That would be the total of those three. Now, you could do one of two things. You could take the 80 plus the 30 plus the 60, and that's going to be 170. That's the same number I had right here. Or you could use the formula that said the number in A or B is equal to the number in A plus the number in B minus the number, I'm just going to put intersection because I'm out of room. So this says, using the numbers originally, the number in A, that's the number for cars, is 110, plus the number that like minivans was 60. No, 90. And 30 like both. So that's 200 minus 30, that's 170. Truthfully, I don't care which method you use to solve the problem. Sometimes the formula that I gave you here is easier. If you're having trouble knowing the formula or whatever, go back and draw yourself a Venn diagram. Okay, I'm right at 26 minutes, so I'm going to quit there, and because I'm out of juice.